Lesson 5.3, we're going to talk about slope-intercept form. We will write and graph linear equations in slope-intercept form and model real-world data with an equation in slope-intercept form. How is a y-intercept related to a flat fee? A cell phone company charges 10 cents per minute plus a flat fee of $5 each month. The slope of the line is 0.1 or 10 cents. It crosses the y-axis at 0.5. The equation of the line is y equals 0.1x, which was the charge per minute or 10 cents, plus $5, which was the flat fee. An equation of the form y equals mx plus b is in slope-intercept form. When an equation is written in this form, you can identify the slope and y-intercept of its graph. And more formally, a linear equation, y equals mx plus b, is written in slope-intercept form, where m is the slope and b is the y-intercept. And we have the algebraic equation. And here we have the graph. So the y-intercept, remember, is where our graph crosses the y-axis, and slope helps us move, so there's our rise and run. Write an equation of the line whose slope is 1/4 and whose y-intercept is -6. Okay, we start with our basic equation, y equals mx plus b. And we're just going to fill in. M, we said, was 1/4. And B, we said, was -6. Now that looks a little odd to have plus -6. It'd be more normal to write y equals 1/4 x minus 6. Next, they ask us to write an equation of the line shown in the graph. This line is going up 4 over 2, or we could have just gone up 2 over 1. So our slope is 2, and it's positive because it's moving up from left to right. And the y-intercept, where the point where the graph crosses the y-axis, is -3. So now we can just plug into the equation. Y equals, the m we found was 2x, and oops, I forgot my negative. So instead of putting plus negative this time, I'm just going to put -3. So we have y equals 2x minus 3. The equation of a vertical line cannot be written in slope-intercept form. I want you to think about why and put that answer in your notes. The equation of a horizontal line can be written in slope-intercept form as y equals 0x plus b, but because 0 times anything is 0, it would just be y equals b. One of the really cool things about slope-intercept form is graphing. Now they wrote this one y equals 0.5x minus 7. We'd rather see the fraction because then we can see our rise over run. So now we know our y-intercept is -7. So we plot that point, and our slope is up 1 over 2. So we can use that to plot our next point. And then we can take a straight edge, draw the line, and voila, we have it graphed very quickly. Now this one we're going to have to solve for y first. So we need to subtract 5x from both sides of the equation. So 4y equals 8 minus 5x. And divide both sides by 4. So y equals 8 divided by 4 is 2 minus 5/4 x. Okay, in slope-intercept form, we're used to seeing it in the other order. Y equals -5/4 x plus 2. But you can see that these are equivalent equations. Now we can graph. The y-intercept for this line is 2, so I plotted a point at 2, and the slope is -5/4. So from 2, we're going to go down 5 over 4, and we can draw a line. If you need more time, you can pause this, and then we're going to go on to a word problem. The ideal maximum heart rate for a 25-year-old who's exercising to burn fat is 117 beats per minute. For every 5 years older than 25, the ideal heart rate drops 3 beats per minute. Write a linear equation to find the ideal maximum heart rate for anyone over 25 who is exercising to burn fat. It's good practice to define the variables. So they said they're going to let R represent the ideal heart rate and A be years older than 25. So from the word problem, the ideal heart rate equals, okay, it's going down 3 beats for every 5 years. So there's our negative 3/5 for the rate of change, or the slope, times A is the number of years older than 25, plus the ideal heart rate for someone that is 25 is 117. So condensing that a little bit, we'd have R equals negative 3/5 A plus 117. Next, they ask us to graph that equation. Hey, if we were going 1 square per box, we didn't need a really big piece of graph paper, so we're going to need to change our scale. Or, like they did, they added a little interrupter. So there's our 1, 2, skip a few, 99, 100. They said, hey, here's 0, but I'm skipping up to 112, 112, 113, 114. And the years above 25, so this would be 26-year-old, 27-year-old, 28-year-old. Okay, so our y-intercept was 117, and then from there we're going down 1, 2, 3, and over 5 to get to our next point. And now they want us to use the equation we just made. Find the ideal maximum heart rate for a person exercising to burn fat who's 55 years old. Now we defined A as years older than 25, so 55, A would equal 55 minus 25 would be 30. So that's what we're going to substitute into our equation. So R equals negative 3/5 times 30 plus 117. So we can cancel, the 5 and the 30 is 6. So I have R equals negative 3 times 6 would be negative 18 plus 117. And negative 18 plus 117 is the same as 117 minus 18, so I'm going to get 99 beats per minute. And here's our summary. The linear equation y equals mx plus b is written in slope-intercept form, where m is the slope and b is the y-intercept. Slope-intercept form allows you to graph an equation quickly because all we have to do is plot the y-intercept and then use rise over run for the slope, and we've got our line.